A friend of mine posted my video on the similarity between large language models, or LLMs, and Markov chains onto a site where they like to opine about this sort of stuff. And it received a bit of a negative response. Oh well. I'm going to post a link above. You may want to watch it if you haven't already. The following will make more sense if you do. So I'm going to suggest an experiment that I think will prove my point. It's already sort of been done, at least once, and I'll tell you about that at the end. Not that I'm obsessed with Markov chains. This is primarily just to illustrate what I think is actually going on when an AI is producing a response to a person's prompting. So a Markov chain text generator is basically formed from two pieces. The first part takes in training text and turns it into a table of statistics about which words come after which other words. And the other part takes this table and then uses it to create randomized output. So the key here, I think, is that there's no reason why these two different things have to happen at exactly the same time. I mean, usually we do, like when you see a Markov chain generator on the web, it takes in an input, immediately produces randomized output from it. It doesn't have to happen at the same time. So I'm suggesting a couple of things here. Number one, take a very large database of some sort and use it to use the loading function to pull in the same sort of training data that you would use to produce an LLM. So basically the whole internet, quadrillions of data points. And the table doesn't have to just be one word look ahead like you would usually use in most Markov chains. So it could be a single word look ahead. It could be 2, 3 words, a sentence, a whole paragraph ahead. And then for each of these, it would be the usual percentage chance mapping that one thing follows the other thing. And then so at the end of this process, there'd be a gigantic database, like I said, probably quadrillions of rows, where you can look up any word you want, and you can get back statistics on the likelihood that the other words or paragraphs or sentences, whatever, would follow on after that word. And then separately from that, we'd have to modify the text generator so that it can also take in an input prompt, because the ones that you'll find on the internet usually are designed to work off the table immediately. So it has to basically take the table and the input that the human is putting in right now and find a way to mix the two together. I have some ideas on how to do that, but there's probably lots of ways to do it. And then from those two things, it would generate a set of output. And now my theory is, given a large enough training set, I suspect the system should be able to produce output that is actually very similar in quality to the early versions of the GPT, say ChatGPT 1 or 2, which if you recall and if you've used them, they're not actually that good. Certainly not compared to anything from the last year or so. So basically what you would get here is something that's producing intelligible output with no AI, no neural network in sight. Just a huge database with statistics and a few lines of code. Now, why do I think this would work? Because it's been done before. I don't know if you recall, but this is basically what Google did when they built Google Translate. I don't know if it still works the same way, but when they first created it, they ingested a huge number of translations from UN documents. And they made a table of statistics about when a word in language A matched up in the translation with the same context in language B. And they built this enormous table from it, and that is basically what they used in order to generate translations. So I don't have the resources, like I said, to perform this kind of experiment. I mean, it would require a server cluster and a large amount of data. Basically the data sets are already sitting around for the foundation models, but to put these things together in the first place is a massive job. But if somebody at internet scale tried this, I would opine that it probably would work pretty well. And really the reason why is because what's going on inside the neural network of a trained AI is it's basically a graph. This particular data point points to that particular data point. The neurons are set up in a way that effectively produces a large graph. And a table with statistics percentage-wise of A maps to B is really actually, I mean, it's a different format, and it's definitely not as flexible, but it's basically doing the same thing. So it should actually work. It might be cheaper to produce. It might be cheaper to operate. I doubt it would be as good or as flexible as an LLM, though. But I think what it would do is it would illustrate the fact that what we have with an LLM is not necessarily thought in the sense that humans are thinking. It really is actually a statistical process. And then with a bit more work, let's say if you layered a knowledge graph over the top of this sort of separated Markov chain generator, you would possibly get something that's almost as good as a foundation model LLM. Again, if not as flexible, but it should work.